welcome. Today we're going to be talking about Mesos, the operating system for your data center. I'm David Greenberg, and I work at 2 Sigma, which is a quantitative investment company. Before we get started, I just want to tell you a little bit about myself and my experience with Mesos. So at work for the past several years, I've been working on a project to build a massive Mesos cluster that runs all of our computational workloads. It's pretty big. It's on the order of tens of thousands of CPUs, but I can't tell you exactly how many. And while we've been doing this, we've been leveraging both open source technologies that work on Mesos, as well as developing our own custom software that runs on top of Mesos. So today, the talk is going to be in 3 parts. First, we'll learn about what is Mesos. We'll learn some of the vocabulary, and we'll learn kind of what it is and where it fits in the stack. Then we'll talk about how you can use Mesos without writing one line of code, the open source ecosystem around it and the community around it. And then finally, we'll talk about how you can build your own applications on Mesos by first looking at the programming model and then looking at some of your options when it comes to developing things on Mesos. So what is Mesos? So the year is 1955, and just a few years ago, the first transistor-based machines were hitting the market. It was mostly vacuum tubes until then. And we have a punch card machine. And we have a couple of engineers. And the first engineer says, hey, are you done with the punch card machine? I really need to load my cards, start my computation. And the other engineer says, well, no, maybe tomorrow. Because punch card machines, you can put one deck in at a time, and they take a while to process. It's 1957 now, and a brilliant engineer comes along, and he says, oh man, what if we all share the same computer at the same time? This engineer was John McCarthy, and he popularized time sharing, among many other things. It was a long time ago, yet again. This time, it was way back in 2005. And this time, instead of being with a punch card machine, we're at some billion-dollar startup based on their cheap IKEA furniture and MacBooks. And again, we have 2 engineers. And the first engineer says, hey, are you done with the Hadoop cluster? I need to run my analytics job. And the other engineer, predictably, says no. He's using the cluster now. Now the year is 2010, and people have become very frustrated with this problem. And so another great engineer comes along and says, what if we all share the cluster at the same time? This engineer is Ben Hindman. He popularized Mesos and is the lead of the Apache Mesos project. The moral of these 2 stories is that the good ideas of today mirror the good ideas of yesteryear. We came up with time-sharing operating systems because we wanted many users to all use the same machines and to run many applications at the same time. And now we can do that with a cluster. Mesos is really an operating system for your data center. And so to show this, for the next few slides, I'll show you where on the left-hand side, we'll see some concept in Linux. And on the right-hand side, we'll see some concept in Mesos, so that we can see how Mesos is just like an operating system. Isolation is something that all operating systems provide. And this is a picture of Homer in an isolation tank. Linux creates isolation through processes. And the way this works is each process has its own private address space. When a process writes to some particular address, no other process can read that data. Similarly, each process has its own private set of file descriptors, so that when you run your web server and you run your proxy, each of their standard outs are going to go to different places. There is not one global standard out for your whole computer. In Linux, we use in Mesos, we use Linux containers for isolation. What Linux containers are is a sort of a lightweight, almost virtual machine that allows you to say, this portion, these CPUs, this memory, is going to be allocated for these processes. And so when we run our applications inside of these Linux containers on Mesos, then you can run 2 or 3 or 4 different systems on the same physical machine, and the Linux containers will ensure that each one gets its allocated quota and that each one is not able to starve the others of network or of disk or of memory or CPU. So on this slide, I'm going to show you a few things that you're not meant to read or understand. I just want to show you them for the sake of their complexity. Here we have a picture of a schedule. And we have people, we have tasks, and there's all kinds of stuff going on. And it's very colorful and very complicated and not something that I would want to do. Linux has something like this, which is the process scheduler. When you run 3 or 4 or 100 applications on Linux, you don't worry about which CPUs each one is going to run on, or whether one program will have to finish before the next one starts. You just trust that Linux is going to ensure that you see reasonable progression of all the applications you're running. Mesos has this as well, in that when you run multiple distributed applications on Mesos, then Mesos ensures that each application gets a piece of your cluster. And as you add more applications, it will scale down existing applications and ensure that you see a reasonably fair sharing of your cluster between all of the applications you want to run on it. The point of this is that sometimes for these problems, you need some really complicated algorithm that you don't understand, but somebody else does, so that you can focus on writing or delivering applications and let somebody else focus on these complex scheduling and sharing problems. Operating systems also provide common infrastructure. In Linux, we have syscalls like read, write, open, bind, and connect. When we want to read or write to the file system, we don't care if it's ext4 or XFS. We just care to say, open this path, read some bytes, write some bytes, and we know the operating system is going to make this work. Similarly, we don't care if we're running in a virtualized network driver or whether we have a Mellanox card or a Broadcom chipset. We just say, bind this socket, connect, send some data, and the operating system deals with the details for us. Mesos has similar things in its infrastructure. It has functions like launch task, kill task, and status update, so that when a distributed application needs to run a process on a remote machine, kill that process, or communicate with it in some way, Mesos handles the details there. You don't need to deal with sockets. You don't need to deal with process IDs and the way that killing a process tree is very complicated. Operating systems also have package managers. We have things like apt-get and yum. And these make it really easy to install applications so that we don't need to go and compile and build every application on every machine that we want to run it on. We just install it and go. Mesos recently got support, first-class support, for Docker. For those of you who don't know, Docker is like a package manager for binary application images, so that you can package up your CentOS user space and your Apache server and run that on an Ubuntu machine. Or you can take really any application, pack it up into a Docker container, and then ship that container around your cluster. With Docker, you can use this as the package manager for your data center so that you don't need to worry about installing a particular application in a particular place. So now that we've talked about how Mesos is like an operating system, let's look a little bit more into what distributed systems are and some of the vocabulary that we use around Mesos. So in Mesos, distributed systems look like this. There's a coordinator, and there's some workers. Now, there are peer-to-peer systems, but those you can sort of think of as a degenerate case of this coordinator-worker model. Now, the way that this works is a coordinator will generate some tasks, send them out to the workers. The workers will compute on them for a while, sending status updates back to the coordinator and sending results back, which the coordinator will use to make new decisions and send out new tasks ad infinitum. Traditionally, what we do in the data center is we partition our workload among several different clusters. So suppose that we want to run Hadoop and Storm. Well then, we're going to have our Hadoop cluster that we pre-create with 5 worker nodes, and our Storm cluster that we create with 3 worker nodes. But suppose now that maybe it's Black Friday, and there's a big spike in traffic, and you really need your Storm cluster to scale up. Well, you can't just take a few of those nodes from Hadoop and shift them over to Storm. You're going to have to undeploy Hadoop from those and then redeploy Storm, possibly even restart your Storm cluster to have it pick up the new nodes. With Mesos, this problem is solved through the way that all problems in computer science are solved, with another layer of indirection. In Mesos, a coordinator, rather than sending tasks to a particular machine, it can negotiate with the Mesos masters. And the Mesos masters can make decisions about how best to partition the cluster. So perhaps what we'll end up seeing is something like this, where we have 2 nodes in the Hadoop cluster and 5 nodes in the Storm cluster. Or we can see it like this, where we've partitioned it completely differently. And with Mesos, by creating this level of indirection, we're no longer fixed to having a particular static layout for our machines. Our jobs can freely be scheduled in one machine or another, and we don't have to make these decisions ahead of time. In Mesos, if you think about what this coordination thing is, what you're really doing is coming up with a schedule where you're saying, do this task, now do this task, now do this task. And so in Mesos, these coordinators are actually called schedulers. So let's fix our earlier slide and say, okay, this is not a coordinator, this is a scheduler. To tie this back to something that you might have used before, in Hadoop, the job tracker would be an example of the scheduler. Now, another important piece of vocabulary for Mesos is what these distributed systems are called. Well, each of these distributed systems that runs on Mesos is a framework. So a framework is a distributed system that has a coordinator. But we don't call it a coordinator. We call it a scheduler. Another way to think about this is that each of these Mesos frameworks is like an app for your cluster. But we're going to continue to call them frameworks because that's what they're called in Mesos. So now that we've seen how Mesos is like an operating system, let's see how you can use it without writing any code. There's tons of flexibility available for open source applications that already run on Mesos. I've just put the logos of a few of them here. Things like Jenkins, Spark, Hadoop, Storm, Cassandra, and also applications that were developed specifically for Mesos, like Marathon and Aurora. There are many more, but we'll only talk about a few of them today. Jenkins is a continuous build server. And what this is, if you haven't yet learned the joys of build server, is every time somebody commits code, your code gets checked out, compiled, and the tests get run for you. So that if some coworker gets lazy or you're trying to compile your code for multiple systems, the machines will let you know when somebody's made a mistake. If you want to use Jenkins with Mesos, it's as easy as just installing a Jenkins plugin and giving it the URI of your Mesos cluster. Now, the benefit of this is that Jenkins can elastically use your spare cluster capacity. So suppose you're running all kinds of stuff on your Mesos cluster. Well, you're not always going to be running your cluster 100%. And in particular, especially if you're working at any kind of consumer web technologies, you're probably seeing a lot of peak traffic when people aren't at work. When you are at work, you have all these spare servers, so why not use them to speed up your builds? This is something that's really easy to do with the Jenkins Mesos plugin. You don't really have to configure anything except set it up. Hadoop is another application, another framework that runs on Mesos. When you run Hadoop on Mesos, you get multi-cluster isolation. So although it is possible to have several users submit their jobs to a Hadoop cluster, if there's not enough slots to run these jobs, they're just going to sit waiting in a queue. But maybe you have something like a production Hadoop pipeline that needs to complete with fixed SLAs. And then you have a bunch of developers and a bunch of projects, and each one of them is experimenting with the types of jobs they want to work. And you want to make sure that all of these different development tasks don't stop each other from proceeding and don't mess up production. With Mesos, you can run all of your Hadoop clusters very easily on top of a single Mesos cluster. And Mesos' resource isolation will ensure that one poorly written job can't have any impact on any of the other Hadoop clusters. Another benefit of Hadoop on Mesos is that you have very fast startup. If you're running Hadoop now on something like AWS or Google Compute, you probably have to wait for 5 to 10 minutes for your VMs to boot and your provisioning software to run and actually set up your Hadoop cluster. With Mesos, everything is already running. And so in just the time it takes for the Java processes to start, you can have a new Hadoop cluster. So in seconds rather than minutes, you can be setting up and tearing down your clusters. To use Hadoop on Mesos, there's a repacked version of the Clojure Hadoop distribution. And this is another thing you can just download and run, and it will bootstrap itself on your Mesos cluster. So we've seen some existing applications and how those can run on Mesos, but there's also some Mesos exclusives that are very compelling. Marathon is a platform as a service that runs on Mesos. And really, most people think of it as the initd for your cluster. And what this means is that Marathon runs in a highly available configuration. so that you can lose several machines and still ensure that any processes you want it to be running will continue running. Similarly, if the machines that are running those processes crash, Marathon will automatically start them up on other machines. Marathon, just like Mesos, has support for Docker. So if you already have Dockerized applications, you have almost no work before you can use this platform as a service for your application. It scales at the click of a button. Marathon's UI has the ability to inspect all of the applications that are running on Mesos so that you can just choose whether you want to have 5 instances or 5,000 instances of your application. Now, for those of you who are worried about this, oh, but my application, where does it start? What port is it on? How do I even connect this up? Like, how do I tie a DNS name to this? Marathon actually has integration with HA proxy so that you can have fixed HA proxy nodes, and Marathon will automatically manage all of your edge routes for you. So it's really a complete platform or a nearly complete platform as a service solution for your Mesos cluster. Chronos is another Mesos exclusive. And what it is distributed cron. You can give it jobs, and you can give those jobs schedules to run them, say, every Monday at midnight, or every third Tuesday, or every 10 minutes. And cron will ensure that those jobs run. And if the machine the job is running on crashes before it completes, Chronos will be able to automatically restart it on another machine. Chronos was built by Airbnb to solve their data pipeline problems. So Chronos actually supports dependencies as well for the jobs. So what you can do is, for your everyday and midnight job that takes all of your analytics and copies them into your Hadoop cluster, once that finishes successfully, then Chronos can start up another job that will import that into some other cluster, or run some set of Hadoop workflows on it. And so you can actually build very complex workflows on Chronos and have those run in a fault-tolerant way without you needing to write any of that fault-tolerant code. Chronos also has a REST API, just like Marathon does. Both of these tools make it easy for you to not only interact with them through a UI, but also interact with them programmatically and control every aspect of their execution, query what's going on, and even make it easier for you to import your existing workloads that you maybe wrote in some other language. Aurora is what I would call an advanced platform as a service from Mesos. It's advanced because, well, it's what powers Twitter. Something like 80 or 90% of all Twitter services run on Aurora, although I don't know exactly because I don't work there and they're pretty secretive. Aurora has some really sophisticated features, things like phased rollouts, so that when you create a new version of the software, you can mark that as a new version and have that first serve 1% of your traffic, then 5%, then 10%, and continue to roll up. And through automated health checks, start doing an automated rollback if it turns out that there's some bug in that software or it's not passing some kind of requirement that you need. It also supports far more complex deployments than Marathon. Not only does it support things like ensure that these servers are not that these processes are not running on the same box, so spread them out between boxes, but you can also make it aware of racks, rows, and data centers. You can tell it about how multiple applications all need to be coordinated, so perhaps it's more beneficial for you to be running logstash on the same node as some application that it's trying to stash the logs of. So Aurora supports these very complex configurations. The downside of this is it's very hard to use, and so the people who do use Aurora tend to interact directly with the Twitter Aurora team, who are very active and happy to answer questions on their mailing list. Spark is another big data system. Well, not really big data, but medium data. It takes the MapReduce problem that Hadoop is kind of the canonical example of, and it does it all in memory. Now, I call this medium data because big data is something where we need a big cluster, and we're writing it all out to disks. It's hundreds of terabytes of data. Small data is something that fits on one machine. I get impatient waiting for more than a couple tens of gigabytes to get processed on a single machine. So medium data is something where it's up to maybe 10 terabytes of data, where you can fit it all in memory. And then you can write much more efficient iterative jobs on it because you don't have to spill out to disk. And so you're not wasting as much time as Hadoop does in each phase. Spark supports querying your data sets with SQL, as well as Java, Python, and Scala. So it's very flexible. And it's also designed for interactive analysis via a REPL, which everybody here should know and love REPLs by now. Spark is something that I think there's a lot of buzz about, but it's not always clear how you can quickly get started. If you have a Mesos cluster, Spark, along with many other new applications, are really easy to get started with, because all you have to do is download them, install them locally, and connect them to the Mesos cluster, and then they can bootstrap their distributed installation for you. So if you want to learn more about how you can actually install and run these applications, you can go to mesosphere.io/learn. They have these nice interactive tutorials that let you type in some information about your Mesos cluster, and then they actually customize the tutorial so that it shows you the exact commands you need to run in order to make these systems work. Everything that I mentioned today is supported and has a tutorial on Mesosphere, but there's also many other frameworks that Mesosphere also has tutorials for that I didn't have time to talk about. So now that we've seen some of the ways you can leverage Mesos through the open source ecosystem, let's see how you can build your own things on Mesos. And in particular, first, let's look at how Mesos works. Traditionally, Mesos is something would be considered a cluster manager. And traditionally, when you use a cluster manager, your application or your human submits a specification to the cluster manager. And a specification has a lot of information about the job. It has every task you want to run. It has the dependencies between these tasks. It has placement constraints, if there are any. Maybe your tasks need to run on GPUs, and so it says only run these on GPUs. The specification contains everything, because in the traditional model, the cluster manager is omniscient. So once you submit your specification, you just wait, and wait, and wait. Now, while we're waiting, it's worth pointing out that there's no reason that we have to wait and not have any feedback. It's just that every cluster manager that anybody really uses doesn't give you any feedback. And so eventually you get a result, and maybe the result, you got a success and you got some data, or maybe it failed and you get to find out why, or maybe you don't get to find out why. So cluster manager, it can be kind of frustrating. And this is due to some of these problems with the specifications. So one of the problems is that it gets very hard to specify some of these constraints that you might have. So going back to we want to run our jobs only on machines with GPUs. Well, maybe what we want is only to run our jobs on GPUs that are no older than 2 years old, because some new thing came out and we have to use that. But one of the GPUs that came out a year ago, there's some bug in it, so we can't use that. So now we have to have this constraint where our job runs on GPUs no older than a certain age, except for some things. Now when we do this, our application needs to have this coded into it so that it can generate the specification properly. But also the cluster manager needs to have this coded into it so that it can schedule it properly. And very quickly, especially if you don't want to be developing a cluster manager yourself, this becomes intractable to create really new types of constraints. Another problem with the specification is that they tend to be very difficult to update dynamically. A thing that Hadoop does is, if there's a few tasks that are running much slower than the rest, they're called stragglers. And Hadoop will start additional instances of those tasks in the hopes that maybe these new instances will run faster and that they'll let your job complete sooner, or with a greater probability of success. If you wanted to do this with a specification, the cluster manager would need to understand the entire notion of stragglers. It would need to understand whether it's safe to run 2 copies of a task at once or not. These are things that are pretty difficult to do. And again, it requires a lot of code in your application and the cluster manager. So Mesos uses a different model. Its model is based on requests. When you want to run a particular task, you request that you run this task. The difference is a request represents what you want to do right now. The specification, remember, talks about the entirety of the job over its entire lifetime. So these requests are much simpler, but they still have this problem. What do we do if we can't satisfy them? We could wait until we can, or we could offer the best thing we have immediately. Now, I think I've made it clear what I think about waiting and waiting for cluster managers to get back to you, especially if you ask for something that doesn't exist, like 1 million CPUs or an exabyte of RAM on one machine. So with this offer model in Mesos, after you make a request, Mesos will say either, oh sure, here you go, you can have these resources now. Or Mesos will say, well, I can't give you that, but you can have fewer resources on that machine, or you can have the same amount in a different machine. And so by doing this, it gives a lot of flexibility to the scheduler so that the scheduler can make the best decision possible given what's currently available for it. This sort of inversion of going from, instead of me requesting, instead receiving offers, it seems a little bit weird. But I think we've actually all worked with this model whenever we've used a non-blocking socket API, say. When you make a write, you give it the socket, the buffer, and how many bytes you would like to write. Now, you don't want to block forever waiting for this thing to complete. So instead, the kernel will come back to you quickly and say, hey, I was only able to complete a part of your write, so let me know when you want to do something different. And so maybe you decide to continue to write in a loop until it's all been written, or maybe you decide to do some other work in the meantime until you think that there's going to be more capacity to finish your write. So this offer model is something that we've all encountered when we've done programming in other applications. So going back to this Mesos model, we have our Mesos cluster, and it's making a bunch of offers to the scheduler. And the scheduler is going to use those offers to decide which tasks to run. So it thinks for a little bit about the different offers it has, it picks a task that it wants to run, and then that task goes and starts running. Now, there's two phases to this, or two levels to this. First, there's the level of offering, and then there's the level of scheduling. This is called two-level scheduling. And in this, Mesos, the Mesos masters, they are making resource allocations. They're deciding your production Hadoop cluster gets 18% of the cluster, and your development Storm cluster gets 4% of the cluster, and so on and so on. But the schedulers, the actual Hadoop or Spark framework or Storm frameworks, they're going to make decisions about what to run next. Do they want to run a mapper or a reducer or a shuffle step next, or whatever they want? This two-level scheduling is something that actually shows up a lot. In particular, it shows up in this user space scheduling, in which the kernel is scheduling on the level of pthreads, and the user space is scheduling with something like green threads or Go routines. And this is the thing that makes it possible so that when you use Erlang, even though it's unlikely that Linux is going to perform very well if you allocated 10 million threads, Erlang is going to be able to create 10 million Erlang processes and multiplex those onto those threads and make scheduling decisions about what should run next. So this is just another way in which Mesos is less like a traditional cluster manager and more like an operating system kernel. Now that you know about some of the available options or about the architecture of Mesos and how you can program against it, there's a lot of options for programming against these APIs. You can write frameworks in Go, Java, Python, Scala, C, C++, and Clojure. And in all of these languages, all these languages have production frameworks running today. I actually wrote the Clojure binding, and that's what we use at 2 Sigma. So the question you should ultimately ask yourself is, should you build it on Mesos? About a month ago was the first MesosCon, and the theme of it organically turned out to be that it's easy to build frameworks. Mesos was designed as a simpler API for developing these frameworks for distributed applications. And a lot of companies and a lot of people are doing this. Companies like 2 Sigma, Netflix, Twitter, and HubSpot all have built open source and proprietary frameworks that run on Mesos. So it's definitely something that is tractable and possible for you to do. But should you really build it on Mesos? Something like 95% of Mesos users are only using Marathon, Hadoop, Spark, and Chronos. They want their platform as a service, their big data pipeline, their scheduled jobs. Because for the most part, this is pretty much all we're doing. And this is really all that everybody's doing. So why did we build our own at 2 Sigma? Well, we have a very exotic workload. It's something kind of like Hadoop, except that instead of having a couple users, we have nearly 100 users who want to share the cluster. And if you total up the runtime of all the jobs submitted over the course of a day, even though our cluster is gigantic and spans several data centers, it would still take more time to clear that queue than we have in a single day. And so we have to be making prioritization decisions constantly to decide what to run next. And these prioritization heuristics are something that we need to be able to control so that our users don't revolt. So we've talked about Mesos and what it is and how it's like an operating system. We've talked about how you can use it with open source software. And we've also talked about how you can build things on Mesos what languages it's available for, the trade-offs you should consider, and what the internal Mesos APIs look like. I tried to time this talk to take only part of the session, so there will be plenty of time for questions. So thank you. Yes?
Who in between the scheduler and Mesos itself, who gets to make the decision about resource deallocation? I'm thinking in particular, you wouldn't be able to shrink a new cluster so small that you cannot maintain replication factor. Is that something that Mesos decides, or where is that handled?
Right, so the question is about whether does Mesos or the scheduler decide how to shrink applications when those resources are required. So this is actually something that is currently under development in Mesos. Currently, what frameworks that shrink do is the scheduler itself knows how to shrink itself. What we're working on right now in the Mesos APIs themselves is something called a reverse offer. So just like Mesos can offer you some resources, it can also ask you to give it something back and tell you how much you need to give back. And so that is going to pave the way for a general preemption solution in Mesos. Yeah.
So how does Mesos interact with this dynamic scheduling and dynamic allocation that Mesos has? How does that interact with persistent things like HDFS stores?
So the question is about how does Mesos interact with long-lived data storage, things like HDFS. So there's two answers to that. The first one is that it doesn't. The way that people solve this now is they allocate the space like the space for HDFS or for Cassandra, they allocate that directly on the host file system, not within the Mesos container. And then what they do is the scheduler itself just remembers where they've put that data so that they can go find it. In the next version of Mesos, they're going to be coming out with something called persistent offers, which is a way for a framework can accept an offer that even when the task dies, the offer is not unaccepted, so that they can hold on to the resources through a maintenance window or through some kind of transient failure. And so persistent offers are an upcoming feature. And once those come out, it's anticipated that there are several companies have already begun working on things like an HDFS framework and a Cassandra framework and an Elasticsearch framework, which Cassandra and Elasticsearch frameworks already exist, but as I said, they are not quite as first class as we'd like them to be. Yeah?
Is there a way to get Mesos to tie into your cloud provider like AWS OpenStack to actually like, oh, I need more nodes, I'm overcommitted, actually go create more nodes?
Yeah, so the question is about whether Mesos can tie into a cloud provider, particularly to do auto-scaling on the cloud provider level. So right now, that is something that is sort of possible. Intrinsically in Mesos, there is no thing that would make you do that, or that would do that automatically. However, Mesos has APIs that you can use to find things out like, what is the current utilization of my cluster? And so something that you could do is write a rule in your favorite rules processing system that just queries the Mesos utilization endpoint and says, if utilization is over some amount, scale up. If it's under some amount, scale down. Now, in addition to this, Netflix at MesosCon announced that they've created a new set of frameworks that are based on a cloud-native Mesos scheduler that actually integrates deeply into the schedule of their application. I believe they do both stream processing and some kind of web services serving thing. And those actually, their scheduler understands how much pressure they're putting on Mesos, and their scheduler then can trigger these auto-scaling requests. Currently, that code is still closed source, but there seemed to be some interest in open sourcing that, and there was definitely a lot of interest in the community. Yeah.
Would this be a good match if you just want to have periods of time where you have nothing up and running? Like you mentioned the benefit of having your cluster already running to get the job done, but you just don't want to waste 10 hours.
Yeah, so the question is Mesos a good fit if you want to have clusters that have long idle periods? So I think that it really depends on your workload there. One thing that you could do is you can scale up and down the number of slaves in your Mesos cluster so that you can keep a few nodes which based on, so there's a website you can go to that automatically creates a Mesos cluster on the Google Cloud platform. And there, I believe it's 50 cents an hour for like a small 5-node Mesos cluster. So it's something where you could have that, and when you need more, you could scale it up, and when you need fewer, you could scale it down. I think the biggest gains that you can get with Mesos, though, are if you're trying to run some mix of batch jobs and stream processing jobs and services so that you can use these spare bits of capacity and either allocate things that are smaller than the allocatable unit that a cloud provider offers, and also allocate things for shorter amounts of time, because most of these cloud providers bill you rounded up to the nearest hour. So Mesos makes it, the big cost savings with Mesos come from when you only want to use something for 5 minutes, or you want to use something that is some fraction of the size of the machines that you buy. Yeah.
So it sounds like with Mesos, you have a 5-cluster cloud, right? A 5-node cloud. So basically, you know that you will, in minimal, use as much space, right? And Mesos kind of the brain to say, hey, I'm going to always need this 5-node cluster, and I want to be smart about how I'm scaling jobs, right? You know, first class citizen, second class citizen, things like that. Is that kind of like a high level, you know, for dummies, how the concept of Mesos?
Yeah, so the question is the sort of the point of where Mesos fits is that it owns the whole cluster, and then it makes it so that it can sort of prioritize and say, this job is more important than this job, and kind of go through like that. Did I understand that correctly? So Mesos does not do prioritization intrinsically. It does support something called resource reservations, so that if you have critical production services, you can ensure that there's always capacity available for them. However, as we mentioned earlier, say you have something like Hadoop, and you allow Hadoop to take over your entire cluster. You would have to ask Hadoop to free up those resources so that some other application can run. However, most Mesos frameworks have the ability to sort of put a cap on how many resources they will use in total. And so instead of trying to, say, prioritize your different applications, the way that you would do this is you would decide that you would know that right now you're not using that capacity, and you can devote it to something else. In the back?
I was wondering if you compare Mesos and Marathon, which were based on CoreOS and Fleet.
On CoreOS and what? Right. So the question is comparing Mesos and Marathon to CoreOS and Fleet. So they're pretty similar, actually. Yeah, they're pretty similar. I think that the difference between Mesos versus CoreOS is that Mesos is something that's been in production at Twitter for something like, I think it's been like 3 or 4 years now. And so with Mesos, you don't just have one application that runs on it. You have dozens of applications. And they're both things that you already use, as well as things that might be interesting to use in the future. So I think that really the thing there is it's a question of, CoreOS is a newer project, whereas Mesos has been running for a longer time. I think that another thing to consider, though, is that Mesos actually would probably be a pretty good fit to run on CoreOS as well. And I think there's a lot of these kind of Docker platform as a service-based things coming out. But Marathon is something that has been, I think even Marathon has been in production in Airbnb for like a couple of years now as well. So there's kind of a longer track record for some of these things and greater flexibility in the overall ecosystem. Yeah. Yeah.
Can Mesos be made network topology aware and control SDN?
So the question is, can Mesos be made network topology aware, and can it control an SDN? No, it can't. But the thing that Mesos does through its 2-level scheduling is that it allows, if you have applications, frameworks running on Mesos, those frameworks can make network topology, they can understand the network topology. So something like the Hadoop framework, although Mesos doesn't know anything about how the HDFS stuff is laid out, the Hadoop framework does, and so the Hadoop scheduler can then make the best decisions that it needs to. And so that's kind of the freedom in the Mesos model, is that rather than trying to make an omniscient cluster manager, it pushes those smarts into each scheduler, so that each component of the system is simpler, but the emergent behavior is more complex. Yeah.
So what's been the biggest pain point for you in the process of deploying and doing all this?
So the question is, what has been the biggest pain point in deploying a big Mesos cluster? So our biggest pain point is something that you won't encounter. Because we operate in a very regulated space, we don't run a standard build of Mesos. We have made extensive customizations to it that, that add pervasive security and ACLs throughout it. Debugging that has been unpleasant to nightmarish, depending on the problem. Yeah. Yeah.
So how would you compare Mesos to Yarn?
The question is Mesos versus Yarn. So I'm biased, but this is sort of, so Yarn is a similar cluster manager that Hadoop has come out, that Hadoop MapReduce version 2 runs on top of Yarn, and Yarn is also a cluster manager. So funny thing, the team that originally created Yarn, their company was also funding the lab while they were building Mesos. Then once they built Mesos, they would call Mesos in, and they would give, and Mesos team would give presentations about it, and the Yarn team would be like, "Ha, offers? This is crazy. This traditional management system is going to be way better." At this point, the Yarn team has actually been revising their API, and they're actually moving it over to offers. And there's also some people working on porting Yarn to run on top of Mesos as well. Not the official Yarn, but a Yarn-compatible API. The main things that Yarn struggles with that Mesos is very good at is Yarn expects all jobs to terminate, whereas Mesos is built for supporting both services that run forever as well as short-term jobs. And then the other thing is that Yarn has some scalability problems. The Yarn cluster the biggest Yarn cluster that I have heard of, and that some people were shocked that it even worked, was 4,000 nodes, whereas there are production Mesos clusters in the 30,000s to 40,000s of nodes. So Mesos is something that has practically, in practice, has better scalability than Yarn. I believe we're out of time, but I will be out in the hallway to answer more questions. Thank you.